All right. Ready to dive into some serious AI today. We're talking Transformers.
Yeah, powerful stuff.
But we're not talking about the robots in disguise, although pretty cool movies, right?
Exactly.
We're diving deep into Transformers All You Need.
Oh, yeah, that paper.
And let me tell you, that title, it's not messing around.
No, it really isn't.
It's dense, but it's like the cheat code to understanding this tech that's, honestly, it's kind of quietly changing everything.
It really is.
Like, you know those super accurate translation apps? Or those AI writing tools that almost feel like magic? Transformers are often the brains behind all that.
Absolutely. And what's so fascinating, I mean, the article itself, it actually draws this really cool parallel to Asterisk, the Matrix Asterisk.
Oh, how so?
That whole idea of, like, rapidly acquiring knowledge, right? Downloading skills straight into your brain.
Okay, so we're not plugging into the Matrix yet.
But not yet. But it feels like we're getting closer.
Right. But okay, before we go full sci-fi on this, we got to set the stage a little. So before Transformers, there were these things called sec-to-sec models.
Ah, yes. Sequence to sequence.
Exactly. So think of it like, I don't know, like translating a sentence, right? You're taking a sequence of words in one language and boom, transforming them into another.
Yeah, that's a great way to put it.
That's sec-to-sec in a nutshell.
And those earlier models, they were impressive for their time, don't get me wrong.
Right.
But Transformers,
Yeah.
they took that basic concept and they turbocharged it.
They said, hold my data.
Exactly. And especially in the field of natural language processing, this was huge. Because think about trying to understand a story, but you can only read one word at a time. Versus, like, grasping that entire narrative flow all at once.
Okay, that's a great analogy. So how did they do that? The article keeps mentioning attention. What does that even mean in, like, an AI context?
So in a way, it's kind of like AI's version of a study montage, right?
I am here for this explanation.
Because in 2017, there was this groundbreaking paper, Attention is All You Need.
Catchy.
And it introduced these things called attention mechanisms. And they completely changed how we process sequential data, like language. So think about how our brains work, right? When you're reading, you're not paying equal attention to every single word on the page.
No way.
You're focusing on the most important ones, right? The ones that carry the meaning.
Right. The ones in bold.
Exactly. And that's essentially what Transformers try to replicate. They selectively focus on different parts of the input data.
So AI learned to highlight.
You got it.
But, okay, there are different ways to highlight, right? Like, sometimes you meticulously underline, and sometimes you just go crazy with a highlighter.
And that is such a good point, because just like our brains have different modes of attention, Transformers, they use several types.
Okay, let's hear it. Hit me with them.
All right, so first up, we've got self-attention. And this is all about understanding the relationships asterisk within asterisk a sequence. So picture this. You're reading a sentence. Your brain automatically connects different words to make sense of it.
Yeah, totally.
That's basically what self-attention does. It's analyzing the connections between words to understand the whole sentence as one cohesive thought.
Okay, so if I'm understanding this right, self-attention is like the AI realizes that hungry and sandwich in the same sentence, those are probably related.
Exactly. Yeah. Now, imagine you're at a party, right? You're scanning the room. You're looking for a familiar face.
Look in there.
Your gaze is shifting, right? Maybe lingering a little longer on some faces, kind of evaluating how important each one seems.
Oh, I know that look.
That is similar to what we call soft attention. So the AI model is weighing the relevance of different elements, just like you were weighing the importance of those faces.
Okay, so self-attention is for understanding relationships within the sequence. Soft attention is about figuring out how important different elements are. What about when you zero in on something, like that laser focus? Does AI have that?
You're thinking of hard attention. And this one, picture a spotlight shining on a single actor on a stage. It's about focusing on one specific element and excluding everything else.
Ah, so it's like when you're scrolling through a menu, your eyes land on triple chocolate cake and everything else just disappears.
Exactly. You got it.
But how do these different attentions, how do they actually work asterisk within the transformer architecture? Because this is starting to sound a little like magic.
It's not magic, but it is pretty ingenious.
All right, I'm intrigued.
And that is where things get really interesting. We'll unpack all those details in just a bit, but essentially these attention mechanisms, they let transformers process information in this completely different way, much more effective than those older models we talked about.
Okay, this is where I usually start to feel like I need a whiteboard and a PhD, but thankfully, You're here to break it down for us.
Happy to help.
Okay, so we've got a handle on the what of attention, but now I gotta ask, how does it actually work in? It can't just be magic happening inside these transformers, right?
Not magic, no.
Mm-hmm.
But it's definitely some pretty elegant engineering. Remember that whole scale dot product attention thing we mentioned earlier?
Vaguely. It sounds kind of intense, to be
Oh,
honest.
I know, right? The name's a mouthful.
Yeah.
But it's actually a pretty cool concept when you break it down. Imagine you're like composing a song, right? And as you're putting together each line, you're not just thinking about the words themselves. You're thinking about how they fit with the melody, the rhythm, the whole vibe you're going for, right?
Yeah, totally. It's all got to flow together.
Exactly. And scale dot product attention. That's basically how the model does the same thing with data. It figures out how all the pieces connect to create that bigger picture.
So it's like the AI is finding those hidden patterns, making sense of how everything relates to everything else.
You got it. It's all about figuring out which parts of the input deserve the most attention in relation to each other. And the scaled part, that just means the model's weighting those relationships, figuring out which ones matter most.
Okay, that makes a lot more sense. And actually, that kind of reminds me of those residual connections we talked about before. Are those also about helping the model keep track of all that information?
You are on fire today. Absolutely. Think about it like this. You're solving a giant puzzle, right? You start putting together smaller sections, but you don't just forget about the pieces you already figured out, right?
Right, you got to keep the big picture in mind.
Exactly. Residual connections, they work in a similar way. They let the model hold on to that important information from earlier steps, even as it's digging deeper into the data.
So, like, it's giving AI a superpower for remembering everything it's learned so far.
Exactly. Photographic memory for data helps prevent it from losing crucial information, which is like super important when you're dealing with these big, complicated sequences of information.
No, you mentioned positional embedding earlier, and I gotta be honest, that one's been bugging me a bit because it seems so simple. It's like you're just telling the AI where each word is in a sentence, right? Why is that such a big deal?
I know, it seems straightforward, but trust me, it's essential. Remember how we talked about sequence being so important in language?
Yeah, word order, all that jazz.
Right, so imagine reading a sentence where all the words are just jumbled up. It'd be pretty hard to understand, right?
Total word salad.
Totally. And positional embedding. It solves that by giving each word this little identifier, tells the AI exactly where it fits in the sequence.
Okay, so it's like those numbered tickets you get at the deli counter, right? Make sure everyone gets served in order. Even though it seems basic, positional embedding, that's what keeps everything organized so the AI can make sense of language. It's like it's all clicking into place now. We've got these attention mechanisms for focusing on the important stuff, residual connections for that superpowered memory, and positional embedding to keep it all in line. It's like we're building this ultimate language processing machine piece by piece.
And the really cool part is all these different parts, they work together so seamlessly within the Transformers architecture. Each one has this crucial role, and they just complement each other so well.
It's seriously impressive stuff. But let's bring it back down to earth for a second, right? We've covered the what and the how of Transformers, but I'm also thinking about the why. Like, why should we even care about all this technical stuff? How are these things actually being used out there in the real world?
That's the exciting part. We're already seeing Transformers making a huge impact in all sorts of applications. Remember those crazy accurate translation apps we were talking about?
Hard to forget those. They're everywhere.
Exactly. Well, Transformers are often the brains behind that.
Wait, so that time I ordered a pizza in Italy using nothing but my phone. Transformers might have been involved in that.
Quite possibly. They've seriously revolutionized machine translation. We're talking faster, more accurate translations than ever before, all thanks to Transformers. And it goes way beyond just switching between languages. Think about those AI writing tools that help you write the perfect email or even come up with different creative text formats. Chances are Transformers are at work behind the scenes there too.
Wow. Okay, so we're talking about some serious language skills here.
Absolutely. They're incredibly good at understanding and processing language, which makes them perfect for all sorts of natural language processing tasks. And we're just getting started.
It's kind of wild to think about, From helping us navigate menus in other languages to, crafting the perfect email, Transformers are already woven into our lives. But it sounds like we're just starting to tap into their potential, right?
Well, absolutely. I mean, they've definitely shaken things up in the world of language processing, but the potential applications here, they go way beyond that. Researchers are looking into using them in all sorts of fields now, like computer vision, even music composition.
Wow. Okay, so from words to images to music, transformers are multi-talented.
Right. And it gets even wilder. They're even being explored for use in drug discovery.
Hold on, drug discovery. Now, how can something designed to understand language help scientists come up with new medicines?
Well, it all comes back to that idea of patterns and connections, right? So molecules, they have structures, and those structures, they dictate how they interact with each other.
Okay, that makes sense.
So by analyzing these patterns, transformers, they might be able to help researchers find promising new drug candidates way faster than with the traditional methods.
That's mind-blowing. It's like we've stumbled onto this whole new approach to problem solving, not just for AI, but for like countless other fields too.
Exactly. And that's what's so exciting about this area of research, right? It's not just about building smarter machines. It's about understanding intelligence itself, how it works, how we can replicate it, how we can use it to tackle some of the biggest challenges out there.
It's definitely given me a whole new perspective on those Transformers all you need excerpts. Who knew something that sounded so, I don't know, technical? Could be so fascinating.
And honestly, we barely scratched the surface. I mean, there's so much more to uncover, like the differences between transformer architectures, the ethical considerations of a technology this powerful, all that good stuff. But hopefully this deep dive, it's given you a good foundation for wrapping your head around this pretty transformative tech.
It definitely has. And for our listeners, if you're feeling that spark of curiosity, don't let it go. Go explore, dive into the research, and hey, maybe you'll be the one teaching AI a thing or two someday. Thanks for joining us on this deep dive into the world of Transformers. We'll catch you next time for another adventure in the world of AI.